Welcome to the Maintainable Software Podcast, where we speak with seasoned practitioners who have helped organizations work past the problems often associated with technical debt and legacy code. I'm your host, Robby Russell. On this episode, we are joined by Tudor Girba, who describes himself as a software environmentalist and is the CEO of Feenk. Feel and think blended together. Tudor Girba, welcome to Maintainable.
Well, thank you for having me.
So, given your experience in the software development industry, what do you believe are a few common characteristics of, let's say, maintainable software code?
Maintainable software code. That's an interesting thing. I think all software is maintainable. The question is at which rate. The other thing about it is that maintainability doesn't depend only on the software. It depends also on the human and on the approach that it is taken to maintain that software. So a lot of the conversations about maintainable software is about just measuring software. But what we found over the last, 18 years of research is that just changing the perspective on how you look at the piece of software can fundamentally change how well another human can engage with that piece of software. So, I definitely don't think that maintainability is a property of software alone.
So not so much as you're saying, software is not a technical problem as much as it is a human. Is it in terms of humans being able to retain and understand the information about the software and or the communication related between software?
Both, yes. Yeah, exactly. And so let's start from the beginning. So I very much like this podcast, by the way, because it talks about something that most developers don't talk about, even if this is what occupies most of the time. So I literally talked with several thousand developers, like literally directly talked with them. And I asked them, do you agree that you're spending at least 50% of your time reading code? And the vast majority does agree with that. And there's quite long-lasting research in this space. I think the first mentioning of this dates back to 1979. But here's the other interesting thing. So the other question that I asked multiple others, but the follow-up question is, when was the last time you heard developers talk about how they read code? So not about the code that they read, but about how they do the reading. And it turns out that nobody talks about it. Now, this is really funny because in business terms, it basically means 50% or more of the time means this is the single largest expense. And this is being spent on one single activity about which nobody talks. So in business terms, right, that doesn't make any sense because if nobody talks about it, it's not explicit. If it's not explicit, it has never been optimized. And this is the largest expense we have. So that's why I very much like this podcast because it makes a subject of conversation about something that I definitely think has to be talked about.
It's interesting. You mentioned that the statistics there, and I think about myself as a software developer and how much time I'm spending reading code of other people or my own code, I think to some degree. We have conversations in our community about improving documentation, making sure our code is readable. But it's interesting to think about what's on the other end of that. Like, what does it mean because that could be perceived as maybe a subjective thing on how readable code is, depending on how you look at that. But now that you've had these conversations, are there ways that you're seeing developers, like what types of conversations do you think they could be having? Is there like literature or guidance for how to go about reading other people's code?
Yeah, that's exactly the thing that we're working on. And so we're developing new kinds of tools and techniques specifically to reinvent how developers read or how, in fact, they should not read code. So let's start from the beginning then. So why do developers read code? They read code because that's where reality is, right? And they need to understand enough, usually, to figure out what to do next. So they don't read the code like they would read, a book like Harry Potter, for example, right? It's a different kind of reading. So in most parts. So when you're learning a new language, for example, you will read code completely differently than when you're working on a system you've been working on for the last year. So let's just talk about the latter case. So in that case, really people read it with a very specific intent of figuring out what to do next. And that's called decision making. Now, given that this is where we're spending most of our time, then perhaps it should make sense to look at software engineering not as much as a construction business, but as a decision-making business. And the way you look and the way you formulate problems is what informs the solutions. So I really believe that it makes a lot of sense to just start systematically talking about what is the nature of the problem we're having. Because if you look at how pervasive, these problems with maintainability are today, it must mean that either we are unable to produce or software is never able to be maintainable, or we are approaching the problem in a fundamentally wrong way. So, for example, there was, in the news not too long ago, there was this story about New Jersey, the governor of New Jersey calling up for COBOL. And of course, there's probably all sorts of political things behind that one. And maybe there was mismanagement or so on and so forth. But at the end of the day, there's a ton of systems out there that we are not able to move anymore. That's not a singular problem. It's not something that, you just push it under the rug. It's a systematic problem. And because it's a systematic problem, we have to stop and look at it. Because if you look at the reach that our industry has, it's all great. Like everything is being reshaped on top of software nowadays. But there is responsibility that comes with that. Up to now, we have not done a good job at being able to produce sustainable systems. That is, systems that are able to live as long as they should. And while they do that, be able to adapt to new changes, right? So these problems with, COBOL and so on, with that system came because the environment has changed, not because the system has changed. And so all of a sudden, some invariants that used to be true are no longer true, and boom, the problem happens. The other thing you look at is very often whenever we think about building systems, we build functionality. We think in terms of functionality. There's a new feature that we're going to add there. But this is not the feature that stops the system from being useful today. It is the structure that doesn't, in whatever form. It can be that maybe it's the deployment of it, but whatever form of it is. It's usually the structure that prevents the system from moving forward. That follows now that if you look at it from a business perspective, it follows that the structure of the system must be as important as the functionality of the system because it impedes business to create value. And again, like when I ask people, do you agree that architecture is as important as functionality, at least in the long run? People overwhelmingly say yes. But then how consequential are we with this kind of realization? So, for example, when it comes to functionality, we have a ton of provisions that ensure that the functionality that we produce has a certain quality, for example, or that certain properties are being preserved whenever we are rolling out a new version or so. So those will come in terms of, for example, tests, but there will be processes, there will be skills that we train people for. And there's a significant amount of investment. And that investment is like an insurance, right? You buy the insurance now in the hope that, when something will happen in the future, these insurance then will pay off in terms of maybe reducing damage, helping you improve diminishing costs to react to that problem in the future. So functionality is a business asset and it is insured as a business asset. It makes a lot of sense. What about architecture or structure? What kind of provisions do we put in place for them to be insured for the long run, right? Do we have automatic tests for our structure? It's such a simple thing. And then in the end, nobody has it. Why? Because we're not talking about it. And because we're not talking about it, it's not a subject of conversation. We're not acting consequentially. And that's why the thing that I think we should start from is making it a subject of conversation. There's lots to talk about it then.
What sort of reasons do you think we suffer from this in the industry? Is it that we've been working with, it's a somewhat mature industry in that we're not talking, we haven't needed historically to have software run for more than a few decades until the last few decades, or is it just like a growing pain that we're dealing with compared to other types of industries where you're building something that needs to last for a long time? Like, I don't know how often I hear developers thinking about this platform needs to still exist in 20 years from now. 10 years maybe, or we can rewrite it by then, or it's going to be a completely different generation of people working on that software. Not my problem to worry about. I think that's interesting there. How have you kind of seen that be kind of discussed with teams as far as how do we put more intention into that? And then also there's that, I would imagine a lot of software starts in a scenario where maybe they're looking for a minimum viable product. And so they're kind of early on in that phase. And he's like, is there even a product market fit for this thing? Or will people be useful in the way we have? It's like a hypothesis that it's going to be useful. So how much infrastructure and investment do we make early on versus down the road? And I feel like there's that arc that people have to get through. And then we're like, okay, now we got to go figure out how to tidy this system up or improve it, add testing or things like that I feel like are maybe more complicated skills to probably teach people earlier on in their career. Like, how do you start introducing better patterns into an existing system versus well, it'll be easier when we start from scratch?
So I think it all starts from how we read code. If we look at the time people spend reading code as actually not being reading code, but trying to make a decision. So it's decision-making time. Then the reading is just the way we extract information out of data. And everything about our system, software systems, is just data. So when you try to understand data to know what to do with it, you don't read. Reading is the most manual possible way in which you can extract information out of data. 10 years ago, I put forward a method which is called Humane Assessment that basically offers a systematic view on how we should not read code and how we can use then the time we spend on reading code to steer agile architecture, for example, and make more effective decisions. But 10 years ago, it was not really obvious how do you not read code. But in the meantime, we have all the advent of data science or around data science. We know that we can take data that is otherwise impenetrable, obscure, and just by changing the look of the data, the form of the data, we can expose the data to people that can make decisions and understand and make decisions about that data in minutes. Now, this is a superpower. This is an amazing power that we can get. It's not the data that has to change. It's the shape of it that has to change. So what does it mean? Because maybe it's a little bit abstract. So how does a usual data science workflow looks like? So we always start from a problem, not from the data. You always start from the problem. And then you say, in order to answer this problem, what data do I need? And then the crucial thing is to create a tool that is highly specific to that problem. Not to the data, it is specific to the problem. That is, you do not know what tool you're going to need before you have the problem. And in most cases, you don't have the tool at all. You have to create it custom made for that specific problem. This is if you follow, this is the process that makes data science effective. And it can generate business value. Now, what do you need to create that tool? Interestingly, software skills. So what I'm suggesting is that every single development problem, every single one of them, includes a tiny data science problem inside. And we should address it exactly with the same idea. That is, we start from the problem, and then we build a tool that matches that problem. We do not start from the source code and from a tool about that source code or running system. We don't start from the tool, we always start from the problem. And what you will find is that in that situation, this ability of crafting a specific tool to match that problem is an essential skill. So since about 5 years, we are now developing the concept of moldable development, which exactly means this. The ability of crafting a custom tool should be part of the development process. And we are practicing this since now 5 years. And I can now say that this is a new way of programming. I've never looked at programming in that way. And now I think completely differently about programming than I was 5 years ago. So to make this thing practical, we're actually building an environment, which is called Glamorous Toolkit. So you can find out about it at gtoolkit.com. This is an open source. Everything we're building is free and open source. And that's because we see ourselves, although we are a company, we see ourselves in the business of education. We want to establish that this reading is a worthy subject of conversation, that there is a whole lot of space to explore there. We think that this is a whole new research area Not that people haven't looked at reading before, they have. And I've done my research in that space. But this way, the idea of creating custom tools for custom problems is a new area, in particular in software engineering. And I think there's a lot to explore in that space. What we find is that this principle is literally applicable at all levels of abstractions. And that is going all the way from how do I look at one single object? Like I put a breakpoint in a debugger and I get an object and I look at an inspector. How do I look at that one? And everybody today, whenever you look at an inspector like that, you'll see, oh, here are the variables and here are the values. That's it. That's what the inspector shows you. But that's not an inviting view, right? It's generic enough that it's applicable to all objects, but that's exactly what makes it not interesting. If on the other hand, right, you think, very often people rely on, let's print a string, right? Maybe I have a two-string or so in the object, and then this will give me much more interesting views. But now, given that this is the 21st century and we are not limited to CRT screens, then we can print a whole widget, because why not? The other thing we learn from the data science space, or visualization as well, is that there is no single perspective from which to look at data. There is no dominant view of anything when it comes to data. Data is shapeless. And code, doesn't matter, even if we are typing code most of the time, that's not text, which just so happens to be using a textual interface to enter our code, but that doesn't make code text. So, by the way, where do we do the reading? In an editor, right? It was not meant for this. It was meant to solve a different problem. And reading and editing, they are not the same. A lot must happen. Like, of course, when the problem fits on a screen, then by all means go read it. But most problems in the maintainability space, they don't fit on a screen, right? And so, I mean, imagine the editor, most developers today, right? They just see a giant text editor right in front of them. And maybe if you're lucky, you will see 50 lines. And then if you turn the monitor upside down and you're on the vertical, then maybe you see 80 lines, right? But you have a million lines of code, right? So you have tens of thousands of screens. So it's like having a magnifier glass attached to you, like the only tool, and then being asked to architect the city. It doesn't make any sense, right? It's perfect for details, but for nothing else, right? And we're asking developers to reason about our systems in those conditions, and that's not particularly humane. And as a consequence, the solutions that are being considered today are off, not by a small amount, but by an order of magnitude, in my opinion.
This whole concept of thinking about the data science workflow that you're touching on. So you mentioned that there's a problem, and then we try to design an approach towards maybe helping us understand. Maybe that's visualization as a way to do that. I think I'm thinking about my own interactions with like interactive programming tools. Like I'm in the Ruby world, and so we've got our IRB world, or we have our breakpoint type tools and binding things so we can dive in and see what's going on at this specific moment with a couple of objects. And you're quite often like, what the hell's going on with this specific one? But there's not like a good way to like get a sense of like, how does this object relate to other objects? What's the state of this? And we're like, you might have to rely on some table data somewhere else. Maybe you've added some internal reporting tools so you can see there, or you have some, there's tools available to generate nice charts and graphs and things that give us like nice counts and statistics, but we're not always able to like, all right, we got a bug report for this type of problem with this type of user. We loaded up that example user. What's atypical between this and a different one? And it's not a quick process to make sense of that whole system. So I think that you're touching on the point of reading as part of that activity. You also make a good point about how we work with editors. So the intention is that we're supposed to be, as software developers, always writing. I don't feel like we have the same conversations we used to maybe have 10, 15 plus years ago, where how many lines of code each day can you produce, when that's not a good, probably not remotely a good metric to be working on. But can you give me some examples of like, you touched on like maybe looking at an object or something, but are there some ways that you've seen where you've had a problem in recent memory where you were able to create some sort of way to look at the problem a little bit different with a tool like Glamorous?
So we're doing this dozens of times per day for every single problem we're having. we're going to build a view that makes sense for that specific problem. And we might throw away that view afterwards. Every single day for every single problem. Just like how people, like used to create code and then we used to create tests and then the code. Now we are creating the view, the test, and the code. And this is how it is. So for a system, for example, if you download Glamorous Toolkit right now, you will have about 800 different views that ship with it. So 800 plugins, basically, already available. And if we would be working on a system using the toolkit, we'd be having somewhere in a ratio of hundreds of views per system built, I don't know, in a 6 months period or so. So that's a usual size. So what kind of problems would those be? So let's say I have a price object. Okay, so just a simple price object. And then this price can be, let's say, it can be added, and then it can be discounted. And then you want to be able to store this thing, so your system should store it in a way that is auditable. So I added this price plus that price, and then I discounted everything by 10% and something like that. So there are multiple ways to describe these things. So one would be we use parentheses and so you'll say, okay, this price plus that price, all of it discounted by something. But now you can imagine drawing, instead of parentheses like that, draw bubbles around them, like visually. And then you can click on every one of those prices in there, and then you're going to inspect just that object in there. That's a simple thing. And this is something that we would very often find ourselves doing. But then it goes further. So, for example, we're looking at a system implemented in React, and people there are having problems with cyclic dependencies between components. Similar problems we find in Angular, by the way. This is like these dependencies. You don't see them very well. They are first of all, they are runtime dependencies. You will only find them at runtime. And the other thing about them is that they are not at the level of JavaScript. You have to be on top of Java. So React and Angular, they add a significant amount of semantics on top of JavaScript, enough to make them a completely different world. So if you just look at it from the angles through the view of JavaScript, then you will not see many things. But unless you take the semantics of React into account. So we had to deal with a system like that. And so we built a diagram that shows that, okay, what are the dependencies between the components that I have? But then you go a step further. So here, this interesting thing here is that this diagram is specific to React in this case, not to a JavaScript. So it's not a generic thing, free for all, everything. But then that was too much. So we narrowed it down to just exactly the kind of thing that we were interested in. So just a few modules. We didn't want to see 1,000 different components. We just wanted to see very, very specifically which ones. But then on all of these tools might be visual. For example, let's say that let's stay with the React example, and say that you need to ensure that all fields are translatable. So you should not hardcode strings there. You need to instead pass the lambda that will translate that string at runtime. So then basically means that once you know how all components use each other, which is just a piece of graph, and you know that every component has properties, and you know which properties of those are strings, then you can write a query now. And in this case, you'll find, give me all the places that are calling these properties and that are hardcoding directly strings there. And now, once you are writing this, again, this query takes into account the specifics of React, but it also should take into account, so for example, certain strings, if the string is wrapped into whatever internationalization framework you're going to use or library, you will have a pattern there for adding that internationalization. And that is allowed. So now your query has to take into account both the nature of React and the nature of this other library. And then you will produce something of value for that specific system. And now you have a query. Now, if you have a query like this then can become a structural test, not a functional test. It tests a functional property, but it checks it in a structural way, because I can just run all the calls to the strings properties should be translated. So these are the kinds of things that go. So it goes all the way from how I look at one individual thing, and it can go all the way to how do I look at large systems. The principle is really always the same.
I keep thinking about, I've worked with different types of engineers over the years, and there's people that tend to think about problems in a very visual way, and there's some people that can maybe also retain some sort of abstract idea, or they're unable to maybe conceptualize something and keep it in their head outside of, so they have to rely on some existing documentation or diagrams. And I've also talked to people saying that they struggle with diagrams because maybe they weren't there when it was created, so they don't really understand, is this updated, is this up to date? So when you're working on these types of things, you mentioned that sometimes they get thrown away. Do some of these types of visualizations or diagrams or tools that you're using to create to help you solve the current problem at hand, do those tend to have more long-term value for other people that when they're getting exposed to the system that you're working on?
Yeah, that's a very cool. It's a very cool problem. So here's what we learned. First, many different people will look at the same problem in different ways, and they will have different needs. However, it's very often maybe 1 in 5 different visualizations will have a reusable value. So in order for this whole thing, like what we're saying is, so now we're going to create a whole tool. Wow, like how much will this cost, right? Because like if this will cost me like a week to build a tool that I have a problem that I should finish in an hour, that doesn't make any sense. We kind of have the similar problem when people were introducing automated tests. At that time, you would have one person would doing testing, another person would doing coding, and usually the person doing coding costed more. And then the proposition was, let's get the coder to also build the test. Woohoo, will this not explode the cost? It turned out that it didn't, right? That if you don't do it, it costs you more. Same thing happens here. So we are showing that we can build tools in a matter of minutes. So we can build things that show you things on the screen about the problem that you care about in a matter of minutes. And when you do this, your ability to iterate and just try this one, try that one, try the other one, goes through the roof. And you have the likelihood of actually finding something that is reusable is much higher. But we aim to amortize the cost of an individual view on the first problem we are solving. So we don't economically, we think that the only way we're going to break this barrier is only if we're able to, the tool will pay off the first time I'm going to use it. If it pays off then we have an economic path to change the trajectory. And we think we're there now. So we know how to do that. Nice.
I'm realizing, as we're talking about this, that it's like I am trying to get a good frame of reference, like trying to visualize this in my mind a little bit. And are there some good places where people could go online and see some tutorials or watch some videos of someone on your team or someone that's using this types of tool to say, here's a problem that we have, here's how, this was like a 1 hour thing, but we were able to kind of pull together some ideas here and show that to some other people, because it seems very abstract in my mind at the moment.
It is. Yeah, I understand that it is. And so first, as a metaphor, think of Excel. Excel, normally you just manipulate tables, but then you can add a chart to it. And it costs you almost nothing to do it. And then you can customize that chart, and then you can add a little bit of glue code somewhere and maybe populate the chart or manipulate the table, whatever. So something of that nature, but right in your IDE. Right now, your IDE is made to click. This is the only thing you can do. Click, 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 click. But your software is highly contextual. As a consequence, we cannot predict. We don't know what your specific problems will be. And as a consequence, I cannot give you a clicking tool. All clicking tools are not solving your problem. They are solving their problem. Because it doesn't matter how shiny the view is. The only thing that matters is, did it change your mind? Or did it even make you smile or so? And if it didn't, then it's not really useful. So we find that the only way to make it useful is to program it ourselves right there on the spot, exactly in the same way as Excel you would do with Excel whenever you have a table, an arbitrary table that just comes in front of you. Where can people go? So gtoolkit.com, that's the website of Glamorous Toolkit. There are some videos there, but downloading Glamorous Toolkit itself, Glamorous Toolkit was developed in this way. It already is a case study. And it exemplifies many of the things inside. So, for example, it comes with a life notebook that it's basically in a class of its own. It comes with slideshows that you just can see right in the development environment live, and you have various kinds of narratives about the inside of the system. But that's what I would go for.
We'll be back with our interview with Tudor in just a moment. Hi, it's me, Robby. I wanted to take a quick moment to say thank you. Thank you for making time to listen to the Maintainable Software podcast. If you're finding these conversations valuable, please consider sharing a link amongst your peers and writing a review on Apple Podcasts and or Stitcher. You can also maybe write a note, a little love note, and leave it on your neighbor's window under their wiper blade. I'm sure they would really appreciate that. Just don't litter, please. Also, do you know someone in the industry that I should be speaking with and interviewing on Maintainable? Shoot me an email to robby@maintainable.fm. And now, back to our interview with Tudor Girba. Do you often find yourself, as you're working with teams you do consulting and service providing for different teams, right?
Yeah.
Does this type of tool work with, and you mentioned React and Angular there, does it work with a lot of different programming languages, or is this?
So it has multiple usages, but it's basically a platform for developing tools that target all sorts of data sources. Some of the data sources are programming languages. We already have support for a dozen of them. But in the tool itself, there's already an extensive platform for adopting other languages. So we very often find ourselves actually working. So one of our areas of work as a consulting company is we go into maybe a legacy system, and sometimes people cannot tell us what the language is of that system. Imagine going into a multi-billion-dollar corporation, looking at their core system, that system that if it stops, the whole company stops within weeks, and getting the documentation about that system, about the language of the system that is not accurate, because that language is a variant of some COBOL and has some macro languages in there that was homegrown, and there's only one interpreter in that company that runs that whole thing. And it's the most critical thing in that whole company, and people cannot tell you what the language is. So we very often we find ourselves in that space quite often, and so in that case you have to go and reverse engineer the whole language and the whole stack. So in order to support decision making, how do I do it? How do I split it? How do I migrate it to a new technology and so on? You need to first of all be able to build up the ability to reason about the space, and then move on. But then even in newer languages, let's say you have a Java system, but that's never a Java system, but it's because it's Java, and maybe it has some Spring, maybe it has some XML descriptors there with this homegrown framework. So it's just like with JavaScript and React. If you do not know what that framework is and what all these extra descriptors are, or maybe you have some YAML, God forbid, or something of that nature. So if you don't take those extra information into account, your view will be off, and not by significantly off. So you have to take that one into account. So we think that the environment of the future is not going to be language specific, but system specific. So when you open an app, you will expect it to maybe share, same look, but it will be organized and show things that are specific to that app and not to the next app next to it. And so why should all the screens, and there's a whole lot of reason why, because we are visual beings, by the way. If you stay 2 meters away from all developers you look at, there's no way you can distinguish what system they work on. I mean, not even the system. We think that even objects should be identifiable. I just look at it and says, oh, this is a fraction, and this other one is a price, and the other one is some chart. Completely different things. They should look different. Why not? And this is an ability we already have. So why not capitalize on that? But in general, like for a system, every system should have an environment that is dedicated to it. And we think that the investment in the tool is an important of an architectural decision as any other major decision people might make, be it language, be it where you deploy, or things like that. That's how I think.
Yeah, this is fascinating. I'm definitely going to spend some time myself looking into this a little bit, because I need to see it to kind of understand it. So it's you're kind of like blowing my mind a little bit here. So you describe yourself as a software environmentalist. What do you mean by that, and how did that come about?
Well, so About 6 years ago, I received a prize for my contributions to software engineering research, and it's a significant prize. And I'm the only one that received that prize at the time from industry. I used to be in academia, but I left 11 years ago. And that's when I coined software environmentalism. So what I see here is that we are creating, like this, what happened with the COBOL systems, all these systems that are there, that are around and we cannot move anymore. These are things that we have created and we are unable to recycle. So we're just focused almost exclusively on creating things without any regards of what's going to happen with these things once they're out there in the wild. And we used to think that, when people named software, they named it as opposite to hardware, right? So like the hardware was big as a house, right? And then the software was this thing that I could put in and out as much as I want. And now the hardware fits in my pocket, but the software is the other way around. And this idea that we can just delete software is just not going to happen. It's going to stop these systems. People are not getting their unemployment right now because a system decides that it's not going to work. So it's not as easy. And we have to think sustainably from the beginning, because otherwise, up to now, we are not behaving any differently from the plastic industry. We're just focused solely on how we're building things cheaper and cheaper, faster and faster. We are throwing those things out there, but we are unable to recall them and do something else, refurbish them for new purposes. And I think that's a major problem. I don't think it's a local problem. I think it's as big a problem as the real environmentalism problem. We don't really see it unless in this kind of at the moment. But if you add to it what happens around AI and what happens around the Internet of Things, the smaller hardware becomes, the more physical software becomes. So that idea, right, that we don't know how, if the environment changes, that how we're going to update the software to match the new environment, to my mind, is unacceptable. And that's so one of our mission is to make the inside of software systems explainable. And this is, I think, it's the prerequisite for creating a more sustainable software environment.
Thanks for kind of diving into that a bit. I think as you're talking about that, I'm thinking about some of the small devices that we've accumulated in recent years. That I realized I found this device that I bought maybe 4 or 5 years ago, and I'm like, oh, I wonder if this thing still works. And it was like it would like help me track how my posture is. And I went to like charge it, and I'm like, oh, maybe I'll start using this again. I went to go download the app on my phone, and I'm like, where's the app? And then go to the website. I'm like, the company's out of business, so I guess I can't use this anymore. And it was like, there's no more software to even take advantage of this physical device anymore. So now it's trash and it's plastic. We're contributing back into the environment now. So it's like software, business, everything kind of being baked in there, kind of a type of problem like that. But I can see how that's going to become more and more of a problem as all of our devices become, I'm air quoting smart, but maybe not always going to be, am I going to have to replace my dishwasher because of some technical debt in the software that some team didn't think about? A few last quick questions for you here. As someone that has worked in academia and has been working in this industry for quite a while now, what non-software development related book do you find yourself most often recommending to people in our industry?
Oh, yeah, that's a good question. One of them is Man's Search for Meaning. We forget in this business that there is a non-analytical part to life. And we're building our systems very often through a lens that fits in a table. Or our requirements, we arrange them in a table. Like we reason when something is plus or minus in that table. But very often the real values, the real things that are valuable in life are not directly quantifiable. And I think that we very often forget that the way we feel is as important as the way we think. Yeah, that's one of the things that I like to recommend.
Nice. You touched on where people can find Glamorous Toolkit online and play with it. Hopefully encourage people to go do that. Where can people best find and follow you online to kind of keep up with your thoughts on? I'll provide some links for the audience to some talks that I was able to find from you that are up on YouTube. But where else can people kind of follow along with your thinking?
So we post a lot on Twitter. I'm to be found there at Girba, at Girba. Our company Feenk, by the way, Feenk comes from feel and think. So you can find us on Twitter at FEENK Feenk.com. And what you will see is that our Twitter feed on the Feenk Twitter feed is actually, these are tiny stories that are being solved visually. And we have sometimes many of those per week. So we go from tiny things. So how do I explain an object to larger things? And we very often, we're even thinking that creating stories about the inside of software systems can be made so exciting as to become a marketing tool. So take Apple. Like one of the things that I'm looking at, I'm just watching all Apple keynotes for whatever reason. And I've watched all of them. And one thing that started to bug me was that by the time when they started introducing the MacBook Air, they started to emphasize the inside of their systems. So their keynotes are huge marketing events. I mean, it's crazy. Like people buy it, tune in to watch a 2-hour commercial. Doesn't make any sense, right? And so the question here was, why would, and now if you go and measure, they might spend like 20% plus of their airtime showing you the inside of a system that they go to enormous lengths to prevent you from ever seeing. Why would they do that? And it bothered me for about, 2 years. And then I think that it's if you look at inside those pictures, they're really beautiful. I mean, the cooler, they make an advertisement out of the cooler of, a MacBook Pro. It doesn't make any sense. And so there's those seemingly boring things, when you spend and you make them beautiful, they generate value that is unquantifiable. And this is what then, if you think of where they started from, when they started to focus on this kind of beauty, the counterparts were like these horrible Dell machines. So even a company like Apple that understands how the beauty of the inside of a system can generate enormous, external value, even a company like Apple never shows you the interior of their software systems. So we think that there is a whole lot of value that we can extract just by showing that interior. And that value is both an engineering tool and it can become a business value as well.
Wow. And an educational tool as well.
Absolutely.
I think that's always one of the challenges in our industry is that there's a lot of conversations about things and a lot of literature that talks about things kind of high level, or when you're starting off to build something from scratch, there's not as easy for people to kind of pull back the curtain and be like, all right, here's like the secret sauce behind this, and sometimes there's patterns and things like that, but it's not always directly related to because everybody feels like that's their proprietary, business value there. It's like, I have this special coder that can do this really amazing design, but there's no value, it's not like someone could just copy and paste that and all of a sudden you have the same application. But it's interesting. I think you make a good point. I have not seen any code from Apple, but it is interesting that they've showed us their insides of their laptops for sure. Maybe one day.
Well, go to our Twitter feed, and then you will see how the interior of our systems look like.
Excellent. We'll definitely include some links to that and to your toolkit and also the book you just recommended, Man's Search for Meaning. It's been such a pleasure having you on Maintainable, Tudor. Thanks for talking shop with us.
Thank you very much for the invitation. It was a pleasure.
Maintainable.